All right, you're going to begin by cutting along that dotted line. So like we talked about in class, when I'm talking about a number, let's call it x. When I find the area of that square, that's called x squared. Now if I go in reverse and I'm given the area y, to go in the reverse order, that is the square root of y. So what you're going to actually do, I want you to fill in. So 1 squared is 1, 2 squared is 4. And I want you to go ahead and do all of the rest through 20. Okay, now let's look at that other paper. On here, you're going to fold it in half. And then there are lines. That's what you're going to cut on. And you're going to cut just until that middle blade point. So now I have my flaps. All right, so let's talk about what are square roots. So I flip that up. So the square root is square root of a is square root of a. Because square root of a times square root of a is equal to a. Now that's a lot to take in. So think about my area as being a units squared. That means that my side length, like we already talked about, is the square root of a. Which makes this one also the square root of a. Okay, and the official names for these, my symbol, this is called the radical symbol. My interior number, this is the radicand. Okay, so that's the official name for that square root symbol and then the interior numbers. Now, when I talk about evaluating, so we talked about the perfect squares. So if I have the square root of 144, think of which square, given the area of 144, what is its side length? Well, this is just 12. Given the square root of 81, if I have an area of 81, what's its side length? That would be 9. Now I can also have negatives on the outside. I cannot have them on the inside. So the square root of 25 is just 5. And I bring that negative out in front. So it'd be negative 5. Okay. Now we're going to talk about how can we approximate. How can we estimate these numbers? So what I want you to do is come up with the closest. So what is the closest perfect square? So for 98, my closest is 100. So I know it's about 10. Right? If I plug that into my calculator, I just hit second square root. I have my square root of 98 equals. So my calculator actually simplifies it. So if yours does that, we're going to go back to classic. I'm going to try it again. Square root of 98. So it's about 9.8, which is pretty close to 10. So back here, this is equal to 9.8. when we round up. Which makes sense. That should be close to 10 because it's closest to square root of 100. Negative square root of 39. I know that's close to, let's see, I have 36 and I have 49. It's closest to 36. So it should be about negative 6. Let's see. So I know it's negative. Let's see, square root 39. It is 6.2. It is 6.2. All right, square root of 55. Let's see, I'm close to 49 and 64. 49 is the closest, so it should be about 7. Let's see, square root of 55, 7.41. Very good. So it should be close to 7. This one is actually 4 when I round. Good. So we've rounded to the nearest hundredth. We've also looked at those close perfect squares. Okay, so that's when I evaluate and estimate. Now we're going to look at when I have expressions. So looking at the top, simplify each expression. We did this during our bell ringer. When I have a square root on the inside, I want to do that first. So square root of 225 is 15 minus 10. So I have 5, and then 15 minus 10 is also 5. 5 times 5 is 25. Okay. B, C, and D, I want you to do on your own. We'll talk about in class.